Hi everyone, this is Vara here with the 6-3 lesson. We're going to talk about logarithmic functions, which you have not seen before, but you'll know all about them by the time we're done. So the first thing we're going to do is convert between a logarithmic function and an exponential function. And remember from section 6-2, an exponential function is one where our variable is in our exponent. Then we're going to evaluate logarithmic expressions, so these are not going to have an equal sign. Then we're going to solve logarithmic equations, so that means we're going to find out what x is equal to. And lastly, we're going to graph. I think in this first video I'll just do the first 3 objectives, and then I'll save the graphing for another video. This next slide shows your formal definition of a logarithm. I'm just going to show you briefly why we need a logarithm. Say I gave you this function and I told you to solve it in terms of x. So you would divide both sides by 2 and you would get this, x equals 1/2 y. No problem, you know how to do that. If I gave you this function, y equals x squared, and I said solve this in terms of x, in other words, get x by itself, you would take the square root of both sides and you would get x equals plus or minus the square root of y. Once again, no problem, you know how to do that. If I gave you y equals 2 to the x, so an exponential function like we looked at in 6-2, and I said solve this in terms of x, you probably would have a little trouble. You might think of trying to take the x root of both sides, but that still doesn't get x alone. That's what we need a logarithmic function for. This y equals 2 to the x, written in terms of x, is equal to x equals the log base 2 of y. So logarithmic functions are the inverse of exponential functions, or you can think logarithmic functions and exponential functions undo each other, similar to x squared and the square root of x. So that's why we have them and why they exist. Okay, now we're going to look at how you convert between an exponential and a log function. So here whoops, didn't mean to do that. You can think about starting with the exponential and converting to the log. So first thing you want to notice is the base on an exponential and the base on the log are going to be the same. So for all of these exponentials we have a base 2, and then when we convert it to a log, the log also has a base 2. This, by the way, is read as log base 2 of 16 equals 4. So that's how we read logs, and the bases will always be the same. So here's my best little trick, I think, for converting between an exponential and a log. So when we're going in this direction, we're starting with an exponential and we're going to a log. Draw these little arrows. Start your first arrow at base 2, point it to 16, and then an arrow from the 16 to the 4. And then this is how you write that. So you start at 2. So if I'm converting to a log, I first write the word log and I say log base 2 because that's where I'm starting. First arrow goes to 16, so I write a 16. So log base 2 of 16. And then I go from 16 to 2. I'm sorry, from 16 to 4, so I say equals 4. And you can see that's what they have over here. So let's look at another one. Log base 2 of 8 equals 3. So start with the word log, base 2, where my arrow starts, of 8. And then the next arrow is equals 3. So this one would be log base 2 of 4. Log base 2 of 4 equals 2. Okay, so these arrows, if you look, log base 2 of 2 equals 1. That's what we have here. Log base 2 of 2 equals 1. Log base 2 of 1 equals 0. Log base 2 of 1 equals 0. Now let me show you, it also works when we're going in the opposite direction. So this would be if we're given a log and we're asked to write the exponential. Same thing, start with your base. Log base 2 of 4 equals 16. Except here, I'm turning it into an exponential, so I just start writing that 2, or you can think 2 to the 4 equals 16, because I'm writing an exponential. 2 to the third equals 8. 2 to the third equals 8. 2 to the second equals 4. 2 to the second equals 4. And you notice these are correct. These make sense. 2 to the fourth does equal 16. 2 to the third does equal 8. 2 to the second does equal 4. Let's look at one of these different looking ones on the bottom. Same idea. Start with your base. 2 to the negative 1. 2 to the negative 1 equals 1/2. And that's true also because 2 to the negative 1 means 1 over 2, which is 1/2. So here, 2 to the negative 2, 2 to the negative 2 equals 1/4. Equals 1/4. So your bases are always going to be the same. Another thing you might have noticed if you maybe aren't following the arrows is your bases are always going to be the same. And if I'm looking at this side, my exponent is what ends up to be on the other side of my equal sign for all of these. So I'm going to have a log base 2, and my negative 1 is going to be on the other side of my equal sign. And if I'm going in this direction, whatever's on this side of my equal sign ends up to be my exponent. So that's another way of doing the conversion. So let's look at, say, this. So I'm going to stop this video here. So we've covered converting between exponentials and logs and kind of an introduction to what logs are. And this video is about 8 minutes, so I think that's good. We'll continue the rest of the lesson on new videos.